Hello everyone, and today we are going to discuss unit tests. The goal of this video and the few others that might come after it, no promises, is that to show you what is unit test, what is it good for, and how can we use it in real life developments that we're doing, both in new development, but also when we are maintaining existing development or things that we have even migrated from Magic. The idea behind unit testing is to take all of those little test programs that we write anyhow when we write code and save them in a way that they will run all the time, every day, all day, making sure that whenever you make any change or write new code or refactor something, the existing functionality of your application would not break. So we'll start by writing a simple CSV writer, and we'll let that CSV writer evolve to match all of our needs and see where that takes us. So first thing I'm going to do, I'm going to start a unit testing project. And I'm going to say add new project, and we'll choose test unit test project. And I'll call it Northwind unit tests. Okay, at this point Visual Studio has created a project for me. The reference is pretty much nothing, only Microsoft Visual Studio, and created the unit test 1 class that we're going to use to write our first test. So let's start with the very basic of testing. Okay, the most basic testing saying is something like this: var a equals 1, var b equals 2, and assert r equal expected 3 when I do a plus b. Okay, this is the very basic test of everything. We build it, and then we'll go to the test Windows Test Explorer, where Visual Studio will show us our test. Let's take it over here, and we have our test here. And when we run our test, okay, run all, Visual Studio will build the test, run it, and show us that it was successful by marking it with this little green checkmark over here and green checkmark over here, and with this blue, with green status bar telling us that everything is okay. Now, if we were to make a mistake, if we would have another test saying a equals 4, okay, we'll rebuild it, have that other test, we'll run all the tests, and we'll see that this test fails. And we'll also see that the entire test suite fails because one failure is not acceptable. So when one thing fails, everything fails. And we know then to fix it, to say, okay, we were expecting to get 6 over here. And when we rebuild the project, we can run all the tests again, and it will be okay. So the idea here is that when we write code, we will start by writing our tests, and write the code that matches those tests, that answers those tests, and work until they're all green, and we live happily ever after. Now, before I continue, I want to introduce you to something that we've done, just another syntax. By default, when you take Microsoft out of the box, you'll use assert r equal. I am more of a fan of behavioral programming, speaking in terms of should be. So to do that, I'm going to go and add a reference to Firefly, which you all use. I'll choose the Firefly box DLL. And I'll add the using here, using Firefly box testing. And now I can write these tests a bit different. Instead of saying assert r equal, I can say a plus b should be 3. And let's look at our text. See that it runs. Cool. Now, it's a matter of style. I prefer this one, but feel free to use assert r equal whenever you want to use it. And one last thing before we're going to start doing things that are interesting, there's this little checkbox over here that we can check, the little button that we can check, which means that whenever we will build, it will run our tests. So if, for example, I'll go ahead and change the 3 to 4, and I will build, the test will run, and I will see immediately indications that they failed. Reducing the cycle from error to knowing that it was wrong to virtually a few seconds. And above all else, I think this is the biggest benefit of testing. you reduce the time from when you do something wrong till you figure out that it was wrong. Because a lot of times you make a change to your code, it breaks something that you're not aware of, and you'll get it back in QA in another month, or from users in 6 months, where you won't remember what you were doing and what you were trying to do. So this is the very, very, very basics of testing. Let's use this methodology to create something useful. Let's create a CSV writer, and we'll do that using the test-driven approach. So commit, cool. Great. So first thing we need to do is figure out what we want to do. We want to write all of our, let's say we want to write all of the customers into a CSV file. Okay. So just like the previous video, let's create a new folder, call it dev demo, and add new item, business process, customers CSV, and we'll say models customers from customers, and we'll add a file writer. Output customers.csv, and we will say override on load. Actually, if I were to write it in the what we feel is the right way, this should have been written there. And streams.add file writer. Remember, streams.add makes sure that the file will be closed when the process completes. That's the goal of the streams.add line. And now we can do in the only row, file writer right line, customers.customer ID, and we'll have our little file. Now to test this, we will put it in the application, saying on start, new dev demo, customer csv.run, and then we'll say exit. This will cause the application to immediately exit, making this run very quickly and without bothering us. So we'll now get in our output directory the customer's CSV file, which will open, and we'll have the customer IDs. Okay. Now the manual way of writing CSVs is starting to, let's first of all save it in version control. And the manual way of writing CSVs would say, okay, plus comma plus customers dot name, etc., etc., etc. But this takes a lot of time to write, complexities, and it doesn't take care of any special things like special cases, special characters, etc. We want to create our own class that will do this for us. Okay? This is the file now that contains customers and customer name. Cool, but we want to do better than this. Hey, in this one you can have a comma in the name, so we can see how it broke into separate columns, which is one of the cases that we need to handle. So let's start by creating the class that we want to write. We'll say here we'll add a new item. We'll call it just class, and we'll say CSV writer. Okay. Public class CSV writer, in this case it's in Northwind. Now when I'm talking about test-driven development, the core idea behind test-driven development is you start by writing a test. Before you even write the code, you write a test to describe what would you like your code to do. Okay. So we'll go to the Northwind unit test project. We'll add a few references that we'll probably need. So we'll add a reference to the Northwind and env, and we'll also add a reference to System Windows Forms, because that's usually required somewhere. And we'll add a new class, add new item. Thank you. We'll go to tests, unit test, and we'll call it test. How do we call that one? CSV writer. CSV writer. And that's a big template that does too much. We don't like big templates that do too much, so we'll delete everything here that we don't want. I'll probably find a better template to use for later. I really hate too much code coming up out there. Not even need this one. Yes, simple, clear. We'll probably find the right template in it later and post it for you. So test CSV writer, you can see we have our class, and you can see that it's annotated with the attribute test class. This indicates that this class contains tests, and Visual Studio knows to search tests in. Next, we'll say using Firefly box testing, because we want to use the should be syntax that we discussed earlier. And now let's start to write our basic class. Void test basic test1. So we created our method, but in order for our method to be recognized as a test, we're going to have to, you see over here it doesn't appear. If we want it to appear here, we need to indicate that it's a test method. By adding the test method attribute, Visual Studio will now recognize it over here. Okay? Now if you want to group it by type to make it easier for us to follow, we'll say group by class. So we have the test CSV writer and the unit test from before, making this easier for us to follow. Okay? So in my dream, I want to say var CW new northwind CSV writer. I want to say CW add Noam and CW add Yael, and then do CW.toString should be Noam, Jeff. The very basic of basics of tests. Okay. So the first thing we see is that this obviously doesn't compile. We can see here that Visual Studio is telling us that CSV writer does not contain a definition for add. It's not aware of that method, which obviously is true because we haven't written it yet. So let's go ahead and write it. So we'll say over here this little light bulb appears on Visual Studio 2015. Previously it used to be a small arrow below it, and we'll tell it please generate a method CSV writer add. And funny enough, CSV writer file has changed, and now we have that add method. Okay, so great. We haven't done anything, and we will run this test now. I can click here run, which is also fun. We will run the test, and we can see that the test has failed. And when we look at the information of why it failed, we can see it here in the basic test output, which is one way, or we can actually see it when we hover, I think, or when we click on it. And it's telling us, well, I expected to get Noma, Yael, but actually got northwind.csv writer. Okay, we used over here the toString method, and the toString method by default gives you the name of the class. Okay, so although the first two characters were great, the rest of the characters were not. And you can see that also it's indicated by the these lines over here. We've created them to show you exactly where the characters don't match anymore, and it was working great when characters were fixed widths, or when you're using fixed width font, which unfortunately I couldn't get Visual Studio to do, only external tools to do. Anyhow, we can see here that this test is failed, and we can now very happily start working on it until it will work. Okay, so we'll go to the CSV writer and we'll say here, cool, it actually tells us that this method was tested once and never passed, which is kind of nice. So we'll say a string result, and we'll say, okay, result plus equals v, and a comma. And then toString return result. Okay? Now, obviously some of you are trying to scream out, although I can't hear you because you're on the other side of the video, that I have too many commas there, which is correct, but I really don't have to care about it because Visual Studio will tell it for me. Okay? I don't need to think so much when I'm working with test-driven development because the test represents the problem and I can very easily see it. So I can see now that Noma, Yael, comma is not the result that I wanted. I don't want the comma at the end. Cool. So now we're gonna take this and match it to be, instead of plus equals v plus equals comma, we'll say if result.length is greater than 0, result plus equals comma. and otherwise just do this. And we'll build it, and our tests will, once we build them, will hopefully pass. Yay! First test working. Cool. So now we can go back to our code and start using our CSV writer. We'll go to our, let's just save this on a version control tool, because I don't do that often enough. And we'll go over to the customer CSV. And instead of writing the line like this, we'll say var CW equal new CSV writer. Okay. And CW add customers.customer ID, CW add customer.company name, and file writer CW to string. Okay, we ran it, and now we can go back to the output directory. We'll see our customer CSV. Let's open it with Notepad, and we can see that it's looking good. And if we put it on Excel, we can see that we are almost good. This column is splitted because of the comma that is within the Alfredo value. Cool. We'll tackle that in a second, but let's go ahead and add a few more columns just to make this interesting. Okay, we'll run this again and open this with text file. Okay, nice. Didn't do what I expected it to do. And let's have a look. Here we are. Let's run it again to make sure that we didn't do any mistakes, or probably we didn't close Excel and it's locking the file. Yes. Hey, love those little mistakes. Don't save the file. Close Excel. Cool. And now our CSV file has more values in it. Okay. So far so good. It's kind of nice. Let's say that we want to first of all have it trimmed. There's no point in using CSV when you waste so many spaces. So let's create a test to verify that we are trimming correctly. Let's say, now I'm not big on writing names for the tests. I know you're supposed to write good names for the tests, but I'm not that good at doing that. So I've ran this, put these two around it. Let's run our tests again. We'll see that basic test was added to our test suite, and you can see that it was failing, because obviously we did not trim it. So we'll go back to our CSV writer and say, well, trim. And we'll run it again. Yes, and this test is bad, so we've taken care of trimming. If now we run no trim, we can see that the result that we've got is now trimmed. Okay, cool. Next thing I want to do, just before we go and handle the special cases, let's go and add support for different values. Okay, for example, I want to say support for all types. I want to say add Noam and add 7, okay, and I want it to work. So I'll go CW2 string should be Noam, 7. Okay, now at this point Visual Studio rightfully says, hey, I don't know how to convert int to string. That is because the add function receives a string as a parameter. So let's go there and say, well, let's receive an object as a parameter. An object is the most basic types, everybody inherits from it, and by saying object, I can send anything to it. The only problem is that it doesn't have the trim method to it. Okay, so let's go and take care of that and say, okay, var equal v to string. Okay, and then we'll say validate. And hopefully this will be enough for our tests to work. We'll build, we'll run, and it's working. Now another test that is worth making is what is going on when we're getting nulls. And null is kind of those special cases that gives everybody a headache and gives you a null exception sometimes. So we need to define what we want to do when we get null, and then do it. And again, I'm looking at tests just like they are the real spec of my application. They define the desired behavior, which then I need to implement. Okay, and they make sure that I don't break anything else. So I'll go ahead and say, okay, let's do test nulls. Test nulls. And I'll say here CW null. And I want it to be null. That's why I decided it's my decision as the developer, designer, architect, whoever wants. But when we run the test, we'll see that we are crashing because we are not allowed to use null. Okay? So, okay. What is the errors that we got? We can see here object reference not set, or again use the cool Visual Studio UI here that shows us that object reference not set to an instance. It's kind of those like I made it to you and you should know why. And let's go ahead and fix that. By the way, you can see here that Visual Studio actually indicates where I got the exception. It tells me I got it in this method, in this line of code, and actually when I click on it, it will go to that method, to the specific line of code that got the exception. So I can use that to improve my code or to fix it. And here I can say, well, if v is null, then use the word null. Okay. And funny enough, it's forgiving me for that. So let's go ahead and run it. Cool. And we can see that it's running, and we can see that it's okay. So we've handled nulls. Should remember to commit on each and every one. But you can see the style of writing. Instead of trying to think of everything in advance and be a big thinker, I'm just writing the test of the extreme cases that I care about, and then I make sure that the test pass. Okay?
And before you write the code.
Before I write the code. Yeah, I write the test before I write the code, and that's why it's called test-driven development. I see the test as the articulation of the application specification. The tests are a language to articulate the application specification. And then the implementation is meaningless. During this demo, as we continue, we'll completely change the implementation, and we know that we can do it safely because we have the tests to make sure that we do it safely. Okay. Now, back to the real case scenario. When we run this application using our nice little CSV writer, we get a good result that looks great. But when we open it in Excel, we can see that because the customer name had a comma in it, I got some kind of an indentation here that I didn't want to get. So first thing I need to do is figure out what the hell do you do when there's a comma in a CSV file. So we'll open a new Excel document and say Noam, Holly, and Yael, and then we'll save it to ctemp test.csv and see what Excel does in this case. So go to ctemp test.csv, we'll open it with Notepad, and we can see that Excel has added quotes around it. So when there is a comma in the value, we should add quotes. Sounds like a cool test. So let's go ahead and close this one, and close this one, and go back to our code. We'll add a new test, which we'll call, by the way, I'm a fan of adding at the top, test comma in value. And we expect it to be comma, Noam, sorry, quotes, and comma, Yael. And obviously when we build this test would fail. Expectedly so. And again, when we'll have a look at it, we can see exactly how it failed. It was expecting a comma there, but didn't find it. And we will then go to our CSV writer and say val.rim. If rim over here. Okay, and then we'll say if val contains comma, then val equals quotes plus val plus quotes. Okay, we'll run all our tests. And we see that we've already fixed that scenario. Let's save the changes. Let's look at the changes for a second so we'll see what we've done. Okay, looks interesting, sounds good. Let's commit it to our version control tool and run it again. We like to keep the test explorer here. So we ran our code and now the file has quotes whenever we had a comma. But as you can see, we've been creative with this value. It also has quotes within the text. So when we'll open this now in Excel, it will probably blow. Surprisingly enough, it didn't. Surprisingly enough, it didn't. It's kind of interesting. I guess it figured out that if it had a quote without a comma next to it, it can take it as it is. Sounds good, sounds cool, but still, let's just play with it a bit more. Let's say that we want to figure out what Excel does in that case. And so let's create a new document. And we'll say Noam, Honig with some kind of quote in it. Noam, the red, Honig with quote in it. And let's save it. ctemp test2.csv, and we'll open it. Notice it's not like that. We want to keep it as a test2.csv. Thank you very much. Yes, we are aware that it's not a good format. Let's open it with Notepad. And we can see that it replaced each quote with a double quote, which is the correct way of doing CSV. And so we need to do the same. So let's do the same. We'll go to our test and add another test saying test quote in value. Test, comma, and quotes in value. And actually, we don't even have to type, we can copy everything. Since I have spelling mistakes, it's always a good solution. So I'll go ahead and copy this here. And I just need to make sure that I put quotes around. Sorry, I didn't want to put it here. I meant to put it in our test. We need this value to test. Okay. In C# you need to do a backslash before the quotes when you want it to use this quote. And so this is the original, and the result should be this. We can take it from Notepad, put it in here. We just need to remember to add a lot of slashes whenever we use quotes. Okay, and a lot of times that's what I do. I actually copy and paste the text instead of writing them, because to make sure that I'm writing them correctly. Now, just to make this interesting, I put it in the wrong place. I made it to be in the one with the quotes, not the one with the comma. So, yeah, I'll just copy the name here and do this. So let's run all our tests, see where we stand. test comma and quotes and value. We can see again where we want to go, what we want to do. Cool. We'll go to our add method and say here that and we'll say here replace, whenever you find quote in it, replace it with double quotes. And let's run our tests. And we can see that it's not working as we expected it to see. Let's see what went wrong. The actual was Noam space. Yes, that's again because we didn't copy and paste correctly. We should have added a space here. Field, tests are running, and we'll get a red light again, which is cool, telling us again that we've done something wrong.
And again with space after the comma.
Yes, space after the comma. So we should say here. And be nice enough to finish. Hey! Cool. So we can see how we've taken our basic algorithm, improved it by adding a lot of functionality to it that takes care of special cases while making sure that everything still works. Cool. Now let's run this. Let's change everything. One of the things that I always wanted to do when I'm working with CSV files is to start treating them as columns. Instead of remembering to put the cells in the right order, okay, I want to put them saying, okay, the first one should be this, the second one should be that, the third one should be whatever. Okay, I want to say here something like, let's do it again in the test, because the test describes what we want to do. Public void test using indexer. Now we have file cw equals new northwind CSV writer. Now say cw dot add Noah, and cw put at position 4. Yeah. Okay. And I expect that when I do this, I will see Noam. This is 0, 1, 2, 3, 4. Yeah. So this is 0, 1, 2, 3, 4. Yeah. That's what I would like to have. And I would like this interface to be cool, so I can say later CW2 equals Yoni, and then Yoni will be here. Okay, this will allow me to construct the CSV in a way that is more natural than just add, something that is more like an indexer. Okay, so again, I'm starting by creating my tests, and this is the APIs that I would like there to be. This is how I determine what I want to do. Now I need to see how do we implement that. Let's see where we are here. Cannot apply indexing with the expression of type CSV writer. And this is where Visual Studio doesn't really help me on doing anything. Let's go ahead and write the code for that. First of all, using an indexer in C#, I'm not sure all of you know how to create an indexer to a class. It's actually quite easy. An indexer is just a kind of a property where I can say a public object, since we want to add objects to it. We say this, which is a special word to make sure that it's an indexer. Open square brackets in index. And then we can say get and set. Okay, and this will work, and I'll be able to do cool things with it. Initially, I'll just return a blank, so we can see that our tests are working, and later we'll implement it. Okay, obviously it failed. We expected to get something, but we only got Noam in it. Okay, because it was the first value we added. And here is what we have now. Cool? Cool. Now, by the way, I don't really need the get, I only need the set, because I only want to set a value. I don't want to get a value, we're not reading out of it. We just want to set a value in. And we need now to find a way to implement this. Now, in this case, I'm going to use a basic list. I'm going to say list object items. Okay? And I'm going to say, well, items at position index is equal to value. Okay, so now I have my little array of values, and when I do add, I'll do items.add value. Okay, and when I write it down, I'll put it all in the toString method. I will say take this from here, put it here, take the result, put it here, eventually return result, and I'll even rename the result to be called just result. Okay?
Okay.
Cool. Now hopefully I've done something right. Let's build everything and run it and see how it goes. First of all, there's a build error. Cool. What's the build error? It's saying yes, you cannot use v over here, and it's correct because we haven't implemented anything that makes sense for it. We should say here for each item v in our items, do this. Okay, we're iterating the items in our list that we've defined over here, and we're adding the values to the result, eventually writing the result. Okay, cool. So all the tests have passed, excluding the ones that we actually wrote, which now gets an index was out of range, must be non-negative and less than the size of the collection. And we can now, because we don't understand what it wants from us, we can go ahead and say, please debug this test. Run it in debug. And we can see that it's saying, okay, the index is out of range. This is the index is 4, but the list only has one item. So we cannot position something at 4 when there's no items before that. Okay, so cool, let's fix that. We can see that the list currently only contains no. Cool. So let's go ahead and fix that. Let's say for int I, no, unequal to 4, while index is less than items count, items add empty. Let's see if it works. It doesn't. Index was still out of bounds. While index is let's say +1, just for the heck of trying. And if we offer
The +1.
Yeah, let's see, it's not in the right place. Let's see again if it will solve everything, or if not, we'll just have to debug. Which is actually a good thing, having to debug. So let's take that away, put a breakpoint here, and say, please debug, select the test. So we have index and item count. Index is smaller. Sorry, it should be the other way around. While index is greater or equal. I always make those stupid mistakes. Cool. And the test has worked and the results are great, just like we expected them to be. So in this case, you could have seen how we completely changed the way we write the CSVs, and we do it safely because we have over 7 tests now that are making sure that everything is working correctly. Now, just 2 more changes before we finish this way too long session of already 38 minutes. And 2 things. One, this code uses a string and uses a plus equals, which is not a good recommendation to do when you want to work with a lot of strings. Because whenever you add something to a string, .NET actually takes the 2 existing strings, creates a new string, puts it in them and continues, and that allocates and drops a lot of memory, something that you don't want to waste if you don't have to. In the recommendation in this case would be to use something called a string builder, okay, which is a class that builds the string but without recreating it all the time. So we'll say here var result equals new string builder, and we'll say result, instead of practice scope, we'll say append, and over here we'll say result append, and we'll return result to string. that is by far superior in terms of performance. And if you're creating large files, you would care about that. Again, we made a fundamental change to the way it works. We ran all the tests, and we can do that safely. Okay, and look how quickly these tests run. It took 2.5 seconds to run everything. Each one of those tests took under 1 millisecond in most cases. Okay, and this one took like 12 milliseconds, which is again a joke. So we replaced the entire underlying implementation and are done with it. And we look again at the changes just to make sure that we've done it right. Voila. So now we see how we replaced it. So to summarize this 40-minute session, a long session, the idea here is to demo how we can use unit tests to improve our development cycle. We can create a test before we write our code, or when we come into new codes that we need to maintain. We focus on that on the second session. We can write a test to help us go through it. And the funny thing here is that we always have written this test. We forever have written this test. We just created a screen to run it and to see the result, or we're using message box. But when we're using the automatic tests that Visual Studio allows us to use, these tests are there forever. So if 10 years from now someone decides the string builder is not the way to go, he wants to use something else, well, he just needs to change it, run the test, and make sure that everything works, because the tests do that for us. And the biggest benefit of tests is, first of all, making sure that everything we've done so far is working and stable, and reducing the time between the time that I write the bug to the time that I get a feedback that it is the bug. I think that changes the development experience the most. Now, we can tell you from our personal experience, when we started Firefly, we started with unit tests 10 years ago. By chance, we fell on the right article and started developing in that manner. And today we have more than 15,000 automatic tests. Think about it, that any bugs that any one of our customers reported to us become one or more tests that we run every day. And that allows us to release every day. Okay, because we know whenever we make a change, we run 15,000 tests. It takes like 2 or 3 minutes. And we know that everything is working. And it allows us to release every day, and it allows us to make dramatic changes to the code every day. I can tell you that in the last 5 years, I've rewrote the recompute mechanism 5 or 10 times. And I've done that while releasing in the same day. I was able to do that because I have literally hundreds of tests that make sure that it works. Okay, so I can do that safely and without any concern. Questions so far?
So now before writing a new code, you think about what you want to write, what you need to test. You write the test and then write the code, implement your wish.
Cool, yes. I use the test to design the API, to think about the API that I want to do, okay, and then write the API accordingly.
Well, this is just the opposite of what we were doing before, years ago, and in Magic also, where we wrote the program and then test it.
Yes.
Usually.
Yes, it's the opposite, and I think it's actually closer to the way even magicians like to think, because magicians like to think about what we want to do, not how we want to do it. And I think that the test describes very, very well what we want to do, what the results that we want to get out of it, and then the implementation is just details that we don't care about.
And it's very clear when you're using the should be. Even if you just look at the code, it's very clear what should be the result.
Yes.
It's very easy.
Yes, when we started, we chose the should be a convention of tests. You know, there's the assert and there's the should be. There's two schools of thought, and there's a lot of articles pro and con each approach. I like the should be because it's descriptive. It's like showing me what I want it to do, what I expect it to do, giving me something descriptive that I can then use and play with. Okay, and I like the way that the code looks like something that I can read, not as code.
Yeah, it's like
Like
story. You
sentence,
can
like a
read
story.
and understand.
Yeah. Cool. So for those of you who stayed so long in this session, thank you so much. In the next session, we're going to cover testing a migrated application, existing code that was migrated, and how we can do that, how can we test the database and play with that a bit. We'll talk about all of those. And that's it for now. Thank you so much for joining, and
Thank you.
see you next time.